Pay attention, Ahmed.
ठीक है जी जी ठीक है सर
जी, हमारा जो टॉपिक है 3.02 सेंटर ऑफ मास. Now you can see on the left side on the book there is a picture where person is taken an scale or horizontal rod, and by the help of thread he has make a balance. Can you do at your home this thing? Can you do this thing at home?
नो सर
No, you can do. Try take something horizontal or scale and try to balance it. So you will find out when you tied up the thread on the center of exact center of the circle scale, you will find out the same position. You have seen this thing in a beam balance. In a beam balance, you can see when the person
ओके
with they will hang in with the center. So both the pans are in equal position. So that is the point of center of gravity or center of mass where whole mass of the body act. So that is the position. If you not get that position, which is exact center, so naturally it will not in this condition. So like other object, the beam on the left is made up of lot of tiny particles, each with the small gravitational force on it. The beam balance when the suspended at one particular point that is called G, because the gravitational force have turning effect about G, which cancel out. When you find out the particular exact point G, so there is no turning effect. It will not go in the anti-clockwise direction or it will not go in the clockwise direction. Together, the small gravitational acts like a single force. Yani all the small particles they behave on this point as one point. In other words, they have a resultant at G, or we can say that it is a resultant force. All the forces are summed on that point. This resultant is beam G is center of mass or center of gravity. Every body has center of gravity. If you particularly focus on that, so you will find out that. Have you seen someone who has walking on the rope or a string? Have you seen?
यस
So how they balance, because they can fell down because they are moving with very they are moving on a very small place, so they can fell down. So how can they manage? They open their arms or they use a big stick to create their center of gravity for maintaining to walk on the rope. Now, next, the next you can see here, they show one is upward force, upward, and then the second one is resultant gravitational force. Both are equal. When both are equal, the body will have no turning effect or no torque.
यस सर
Find the center of gravity of mass. In the diagram 1 below the card. Now I'm showing that thing. Now, now in this figure, you can see the shape of a card is irregular. It is not a regular.
यस
So if you position in such way in the diagram 1. So we are studying the card can swing freely from the pin. अगर आप एक पिन से इसको अटैच कर लें और उसको आप रोटेट करें तो वो इधर उधर एक तरफ मूव करेगा और एक जगह पे रुक जाएगा, सेटल हो जाएगा. When the card is released, the force on it turns the card till its center of mass is vertically under the pin. Diagram number 2, whichever point the card is suspended from it, it always hangs with its center of mass vertically under the pin. This fact can be used to find out the center of mass. देखिए, यहाँ पे पिन ऊपर की तरफ लगाई गई. ये जरूरी नहीं है कि पिन ऊपर की तरफ हो. ये जब स्विंग करेगा इजीली तो एक जगह पे रुक जाएगा. That point is that particular point is the center of mass. In the third
Okay.
diagram, in the third diagram, the center of mass lies somewhere along the plumb line. What is plumb line? Normally, masons use this thing. मेसन कौन होते हैं? जो मजदूर होते हैं जो घरों को बनाते हैं,
जी
जो
जी
लाइन का इस्तेमाल करते हैं. सही है, दीवार को सीधे रखते हैं. तो अब वो उसके साथ
जी
और उसको आप वो लटकाते तो वो सीधा उसी की तरफ जाती है. तो उस प्लग लाइन का इस्तेमाल करें तो हमें पता लगेगा कि अगर यहाँ पे हमने लटकाया था तो हमने ए पे निशान लगाएंगे. अब हम यहाँ पे लटकाया था तो ए से लेकर बी तक आपने निशान लगा लिया. फिर आप पॉइंट डी पे लटकाएंगे तो वहां से एक लाइन आ जाएगी जहां पर मोस्ट ऑफ द लाइंस कट करेंगी. दैट पॉइंट इज द सेंटर ऑफ ग्रेविटी whose position is marked by the line AB. If the card is suspended at different points and the second line is CD can be drawn, the center of mass must be like lies along this line. So it is at the point where AB and CD crosses to each other. I hope you can understand. If you have any,
yes sir.
you can ask. If you have any query, you can ask.
Sir,
No?
no.
Okay. We are moving towards our next question. Now here you can see heavy bar problem. Heavy bar problem. Now see here in the diagram you can see there is a point where I am showing my cursor. You can see my cursor.
Yes.
From here to the weight is 0.2 meter. And from the corner to the next corner it is 1 meter, and the weight is here 1.5 kg. Okay. Now
Yes sir.
why is this? Because because
Because sir, the distance is more and weight is uh, also
less
high.
less,
Less. Yes.
and on the second one force is less and distance is
Yes. High.
more. Now, in this, in the simple problem, you can often told that a balance bar has negligible weight. In more complicated problem, you have including the weight. वो कहता है कि इन किस्म के मार्क्स जो क्वेश्चंस होते हैं इसमें हम बार के वेट को नहीं लेते. सही है. Example,
G.
if you have uniform balance as on the left with 1.5 mass attached with the one hand, what is the weight? What is the weight if G is 10 Newton kg? So for this purpose, what we have to do or find out the center of mass, actual weight.
Okay. Sir.
To solve this problem, redraw the diagram to show all the forces and the distance. as in the lower diagram. Now you can see here we have divided this thing. Now this where I am showing my cursor, it is zero point 0.2, and when we minus zero point 0.2 by this value, it becomes 7 point. Now this value is 1. If we make it half, it will be zero point 0.5. It
Yes, sir.
will be 0.5, and from zero point 0.5 we minus zero point 0.2, so this will be the answer of 0.3. Now there are three forces acting out here. One is the weight of the bar, second is upward force by the support, and which is
Yes.
upward, and third one is going downward, which is 15 Newton. Now from this we can find out the weight of the body or weight of the bar. Now 15 multiplied by
2.
0.2. So this
Yeah.
will be the anti-clockwise torque. This will be anti-clockwise.
Anti-clockwise.
Now second thing is W multiplied by 0.3. That is clockwise torque.
Clockwise movement.
When we multiply by 15 by 2 and divided by 0.3, we get the simple answer W is equal to 10 Newton.
Okay.
Okay. Now,
Ji,
we
sir.
are going towards our next topic. Now, here you can see there are one card is on the vertical direction. So both the forces are equal to each other, and now it is in the state of equilibrium. When a small tilted force will turn the box block in this ओरिजिनल पोजीशन. अगर फॉर एग्जांपल हम इसको थोड़ा सा हिलाते हैं तो क्या होगा? इट विल चेंज
इसकी
इट्स
पोजीशन चेंज हो जाएगी.
पोजीशन. क्या हो जाएगी? चेंज हो
चेंज
जाएगी.
हो जाएगी.
सही है. नंबर वन फिगर. Number one figure, this box is in equilibrium. The force on it are balanced. So there there are no turning effect.
Yes.
With a small tilt, the force will turn the box back to its original position. थोड़ा सा आप हिलाओगे तो ये क्या
हम्म.
करेगा? वापस अपनी पोजीशन पे आ सकता है.
वापस अपनी पोजीशन बाहर.
With the large tilt, the force will triple द बॉक्स ओवर. अब अगर ज्यादा करेंगे तो फिर ये वापस अपनी पोजीशन पे नहीं आएगा. ठीक है, आपकी बात समझ में आ रही है? इफ द बॉक्स
जी, जी, सर.
पुश a tilt and turn, release and then release, it fall back to its original position. So its position was stable. If the box is pushed more further, it topple it start to topple, so soon its center of mass passes over the X. So its base. From then on the force, the box have a turning effect, which tips it even further. A box with a wider base or lower center of mass, more stable. It can
Yes, sir.
to the greater angle before it start toppling. Now we will see the next figure. Now here three positions are showing where. Number one, cone. You have seen a cone which have wider base. So this position is a stable position. When you tilt this thing from its head, it will most of the chance that they come back to its original position. Now in the second figure, now the cone on the sharp edge, standing on the sharp edge. Now, if you provide him a small tilt, so it is more chances that it will not come on its original position, that is called
Position.
stable equilibrium.
Unstable.
And third one is neutral equilibrium. You, if you have a football or ball, so its center of gravity lies on the center. That's why when you roll it or tilt,
It,
so it will roll down but never change its center of gravity. So this is called
yes.
neutral equilibrium. I hope that you are able to understand this thing. Now there are some questions below. If you have any query, you can ask me. Sir, I'm waiting here. If you have
जी सर.
any query, अगर आपको कोई सवाल पूछ
सर, I'm in.
तो पूछ सकते हैं.
जी सर, 1 minute.
Yes, sir. Any problem? No?
सर ये क्वेश्चन, सर क्वेश्चन नंबर 2,
A uniform rod with
पार्ट ए.
4 Newton weight hanging from one end. कहता है एक रूलर है जिस पर 4 न्यूटन का वेट एक एंड पे लगा हुआ है. इज द रूलर बैलेंस व्हेन सपोर्ट फ्रॉम अ पॉइंट 0.1 मीटर फ्रॉम द एंड. सही है, ये वही फिगर है, वही
जी
सवाल
सर.
अभी आपको करवाया था, वही सवाल है ये. सही है.
अच्छा.
अब वो कह रहा है सपोर्ट जो है ना, जो एक एक जगह पे तो वेट लगा हुआ है और दूसरी तरफ
हम्म.
सपोर्ट है 0.1 मीटर के फासले में. ड्रॉ द डायग्राम, शो द रूलर एंड द फोर्सेस ऑन इट. आपको सिर्फ फोर्सेस शो करनी है. कैलकुलेट द वेट ऑफ द रूलर, और आपको वेट ऑफ द रूलर मालूम करना है. तो अभी पिछले जो पेज पे हमने क्वेश्चन किया था,
अच्छा.
क्वेश्चन है. सही है. अच्छा जी. ड्रॉ द डायग्राम.
ओके.
Draw the diagram to show the drawing pin position, stable, stable, unstable and neutral equilibrium. थंब पिन होती है ना, थंब पिन. थंब पिन की आपने फिगर बनानी है. थंब पिन को आपने
जी.
ऐसे करके रखना है जहाँ पे उसका जो जो फेस वाला जो हिस्सा होता है वो नीचे की तरफ हो, फिर पिन वाला हिस्सा हो. सही है. और फिर इसी तरह आपने न्यूट्रल कंडीशन में दिखाना है, तो आप उसको लिटा देते हैं ना, तो फिर वो घूमती रहती है, अपनी पोजीशन को चेंज नहीं करती. इसकी ड्राइंग आपने बनानी है.
ओके.
ओके. ओके बाबा, ओके. नाउ एनी प्रॉब्लम? मैं क्लास ख़त्म करना चाह रहा हूँ क्योंकि टाइम ओवर हो गया है, और मुझे उम्मीद है कि ये चीज़ समझ में आई होगी, और यही चीज़ हम जो है ना अपलोड भी कर देंगे. ओके. या फिर